All right, guys, so we're getting really close to the end of everything, that we need to learn for the school year. So we're starting chapter 9, data analysis, which what data analysis is graphs, reading them, being able to answer questions with them. So we're going to start with scatter plots. So scatter plots. Okay, so I'm going to read the TEK. Don't judge me. I'm going to read the TEK so you can understand what you need to know when we're done with today. If you don't understand this, you probably aren't going to be successful on your test. All right, so, okay, we're going to learn how to construct a scatter plot and describe the observed data to address questions of the associations such as linear and nonlinear and no association between bivariate data. Okay, so we know what linear, nonlinear. So you can look at a graph and you can tell, especially a scatter plot, is it all mixed up, scattered everywhere? That's nonlinear. If it's kind of in a line, that's going to be a linear scatter plot. Okay, we need to be able to look at a graph and be able to understand it and then answer questions. So a really good thing is if you can construct one, build one. If I can give you information and you can make a scatter plot, then that means you probably understand what a scatter plot is and you're going to be pretty successful with it. Okay, so let's get into some examples. Okay, first let's talk about 3 types of association. I feel like I need to get closer because I feel like you can't see the dots. Okay, so look, right here we have, do you see how these dots are kind of close? This is semi-linear, right? And they're going up. They're going up. That's a positive association, right? Okay, because it's going up. So as your x is increasing, as our x gets bigger, our y is increasing, okay? Then we have this one, okay? Obviously, these are falling. It's opposite. See, these are going up. These are falling down. So as our x increases, let me read this correctly. As our x increases, our y decreases, okay? So look at this. So look, this is a negative association because we are falling, okay? And then, my favorite one, this is no association. There is no association. There's just scatter plots like chicken pox everywhere. So this would be no association. So those are your 3 types of association. Next, we will get into some examples, okay? I'm going to do a screen recording because it's just a lot easier. So we're going to describe the association, if any, among the observed data for each of these scatter plots. So you can see my mouse. You can see we're going to start on number 1. So we have right here, games 1. So always you should look at what is going on. What is this graph? What kind of information is it giving me? Here's the games 1. So we are going up by 2s, 2, 4, 6, 8, 10. And then the average game attendance. So like how many people are coming. So you can kind of see that, at the 9th game, there's about 100 people there. A 9th game 1 or whatever. So it kind of looks like, I don't know. So let's look. Let's answer this question. Is there association with this? Is there any association? No, there is no association with this. The game attendance does not affect the games won. So this is like one of those where you would say home field advantage. So if you're playing a game at home, they always say you have an advantage because you have a bigger crowd. Well, you're not winning. Games winning has nothing to do with how many people are there, basically. Okay, so let's look at this one. This number 2, car value, the percent of cost of a new car, and then the car age or year, okay? So it looks like, I don't know why this is doing this, guys, sorry. So it looks like that this is falling down, right? And that's going to be negative because it's falling down, and it is somewhat of a line. It's somewhat linear, So negative, and as the age of the car increases, the value of the car decreases. There appears to be a linear association. It appears to be linear. To me, it does too. I mean, I know you got some outliers. I know we've heard that word before, the ones that lie a little outside the data. But for overall, this does appear to be linear. All right, now let's look at number 3, pumpkin weight in pounds, and then the growth time. So this obviously is getting bigger. So here is the pounds. So let's look at 50-pound pumpkin in 150 days. A pumpkin can grow to be 50 pounds in about 150 days. So I would obviously say that obviously it's going up. So this is a positive association, right? And it is somewhat linear. Okay. So as the growth time increases, the pumpkin weight increases. So there appears to be it kind of appears to be like non-linear association because of the little dip, but it is a positive association. It'd be kind of iffy. I would not call this like really linear because that big dip and that gap right there. But overall, it is a positive association. So we have no association, negative association, and then a positive association.